Okay, so let's talk about lipid transport really quickly. So, first of all, we have to understand two states, the fed state and the fasted state. Let's talk about the fed state first. When you eat a fatty meal, it's going to go into your system, and in your duodenum, it's going to be broken down by a pancreatic enzyme called lipase. Now, when you break down fats, it becomes a molecule called triglycerides. This triglycerides can be used by the rest of your body. Before it does that, and before it enters into the bloodstream to go where it wants to get, it needs to be packaged into this round structure called a chylomicron. So a chylomicron is just the housing to dump out this triglyceride into the rest of your body. But first, it needs to have a special protein on its surface called ApoB48. And the reason why you need ApoB48 is because after it dumps out its triglycerides around your body for energy for the cells, it's going to go back to the liver empty, and it's going to come into the liver to get repurposed and everything, because the liver does have an ApoB48 receptor. Now, that was when you were fed. What about when you are starving? How do you get the fat that you have into your cells for energy? So this is where the liver comes in. You have two things, lipid transport mechanisms that the liver can make. So VLDL, which is very low dense lipoprotein, and HDL, high dense lipoprotein. So you might have heard that high density lipoprotein is good, whereas VLDL is bad, or LDL. And this is because before we talk about this, we can understand that VLDL takes fats from the liver and puts it into the periphery, right? This would mean that you're moving around quite a bit of cholesterol, and your cholesterol can be high. And we know that's bad because that can cause atherosclerosis and such. But HDL sort of does the opposite things. It takes the fat from your periphery and then dumps it into your liver, which can be excreted as well. So HDL is good, LDL is bad. However, if you are starving, LDL is good. So let's talk about the VLDL pathway quickly. So the VLDL is another circled structure you can think of, which houses triglycerides, fats, and what have you. So it does enter into your bloodstream, and it also does dump out fats to your other cells, just like chylomicrons do. However, there are a few caveats here. So instead of ApoB48, it's going to have ApoB100, and this is again to make sure it does, once it's out of fats, comes back to the liver and gets repurposed. But it doesn't come back to the liver as VLDL. After becoming VLDL from the liver and having lipoprotein lipases on your peripheral cells break down the fats to use the triglycerides, it becomes something called an IDL, an intermediate dense lipoprotein. And furthermore, if it's broken down even further, it's going to become an LDL. So quickly, I just want to talk about VLDL and IDL. Both have an ApoB100 receptor on them, so they can go back to the liver to be repurposed. However, the last stage, when you go from an IDL to an LDL, the LDL doesn't have an ApoB48 receptor. In fact, there is a special receptor on the liver called an LDL receptor for the LDL. So it's just semantics here, but all of them do go back to the liver. So let's talk about HDL now then. If I talk about the fed state and the fasting state, then what purpose could HDL possibly have? Well, HDL essentially is the good thing that I talked about. It's the good guy. So he mediates reverse cholesterol transport from the periphery, like the rest of your body, back into your liver. So it also sort of helps VLDL in its job, right? It has these apolipoproteins. It doesn't have B48, it doesn't have B100, but in fact it has apolipoprotein C and E. So what apolipoprotein C does is that what HDL does is it gives apolipoprotein C to the VLDLs or the chylomicrons, who are transporting the fat to the peripheral tissues that need the fat. But of course, fat needs to be broken down into triglycerides. So, as I mentioned before, lipoprotein lipase breaks down fats from the chylomicrons from the VLDLs to be used as triglycerides. But for LPL, lipoprotein lipase, to actually work, you need ApoC2, right? And ApoC2 is a cofactor for lipoprotein lipase, which comes from HDL. So you can think of HDL as a repository for apolipoC2. Now it also has apolipoprotein E, and this just means that it helps with the reuptake of VLDL, IDL, chylomicron remnants. It's just another thing that helps them get back, find their way home to the liver.